Here's problem 11.22. Diagram below shows 5 cylinders, each cylinder rotating with constant angular velocity about a central axis. The magnitude of the tangential velocity of one point of the cylinder is shown, along with each cylinder's radius and mass. Which cylinder has the largest angular momentum? In general, our angular momentum is going to be equal to the moment of inertia times the angular velocity. And for a cylinder, the moment of inertia is 1/2 mr squared. The angular velocity will be equal to the linear velocity at that point divided by the radius to that point, with one of these radiuses canceling out. This gives us 1/2 mvr. So that is going to be our angular momentum in general for these cases. So as we look at L1, we are going to have 1/2 times the mass, 20, times the velocity 2, times r to that point 2, so that's going to be equal to 40 kilogram meters squared per second. For the second one, we're going to have 1/2 the mass, which is 10, times the velocity 4, times the radius 2, which is going to be 40. I'm just going to leave the units out for the moment. For the third one, we're going to have 1/2 times the mass, 10, times the velocity 2, times r, 2, which will give us 20. For the fourth one here, we're going to have 1/2 times the mass, 10, times the velocity 2, times r, which is 4, which is 40. And for this last one, L5, we're going to have 1/2 times the mass, which is 20, times the velocity, which is 4, times r, which is 2. 4 times 20 is 80. So all these being kilogram meters squared per second, this last one has the largest angular momentum, 1/2 mvr, 80 kilogram meters squared per second. So that's our answer. This last one has the largest angular momentum about the rotation axis.